Hello everybody, my name is Mike Guide, and in this video we are going to add collision detection to our Allegro 5 game. Now up until this point, we have our ship object, our bullets, and our comets all on the screen, all being updated, all moving appropriately. However, they don't interact with each other, and that is primarily what makes this game work, is the interaction between the ship, the bullets, and the comets. And so we're going to look at adding that in the form of collision. Now we're going to look at two different ways to handle collision in this game, but I want you to remember, to keep in mind, that collision is an art of good enough. And what that means is that until you get into things like pixel perfect collision detection, which can be very taxing on the system, we're gonna vie for collision detection that's simple but accurate enough. So basically, we don't want it to be so inaccurate that obvious hits are registered as misses, or obvious misses are registered as hits, but we don't want it so accurate that it actually bogs down our system. We added into our objects previously the bound X and the bound Y, and you can see that here in our objects.h. You see our bound X and our bound Y, and effectively what that is the bounding box for our objects. What essentially that means, I don't want to get too much into the theory of collision detection in this video, but what effectively that means is when we collide with an object, we're not going to collide with the actual graphical representation of that object. We're going to collide with the bounding box of that object, or the hit box. And when we declared or initialized our objects, we gave it a bound X and bound Y value, and what I intentionally did is I made that bounding box slightly smaller than the actual graphics of the image. So for instance, if in the case of the comet, which is a circle, the bounding box is actually a square that's slightly smaller than that circle. So that the reason we do that is, one, it's easier to do collision detection with boxes. That way we don't have to get any trigonometry functions involved. And two, we don't have any registered hits that aren't actually part of the object. If you think about it, the bullet is so small and it's traveling so fast that if it actually enters into the comet before registering a collision, the player's not going to be able to see it. It's too fast. But if the bullet misses the comet but still registers a hit on the comet, you're going to be able to notice that. So we err on the side of a smaller bounding box, which provides more accurate collision detection. And we'll look at that here. We're only going to be adding two functions to this game. We're going to be adding collide bullet and collide comet. So I'm going to come up here to my prototypes. I'm going to type void collide bullet. Now for the purposes of this game, bullets cannot collide with the ship. The bullets are fired from the ship. The enemy does not fire bullets, so I don't need to do any checking on the ship. So it makes it real simple. So what I'm going to do is I'm going to pass into that our array of bullets, sides of the array, and then our array of comets. Alright, so that will be our collision detection. Oh, what did I type here? There we go, that's fixed. So what we're going to do is we are just going to check the collision of the bullet, or of all of our bullets, against all of our potential comets. So let me come down here. You'll see that I've minimized all these functions down by hitting the minus sign next to them. Makes it easier to see all of our functions at once. I'm going to go ahead with our definition here. Or I type comment, I'm going to bullet. This becomes real easy. Essentially, we have to iterate through the array of bullets, finding only the live bullets, and then iterate through the array of comets, finding only the live comets, and testing to see if any of them are inside of each other. And that is inside of each other is an integral part of collision detection, and it is basically the fundamental of collision detection. And we'll look at that here in just a second. Oh, you know, I made a mistake too. Let me come back up here I have bullet and then bullet, which is our array of bullets, and then size. And my mistake, let's call that B size, because we need to differentiate the sizes. And then we have comet and then commits, and I wasn't thinking when I was typing. I was thinking ahead there, so I didn't name those something reasonable. So we're gonna do int C size for size of our comment array. So I apologize for that. Let's come back down here and let's call this B size and C size. I get so ahead of myself I forget what I'm doing. All right, so let's go ahead with our nested for loop. So I'm gonna do int I equals 0, I is less than B size, I plus plus. All right, and then if bullet sub I dot live. So we're only testing live bullets. Now we're going to iterate through our comment. So int j equals 0, j is less than C size, j is plus. Now here is first if comments sub j dot live. Okay, so here is the fundamental of collision detection. All right, so basically we know a collision has occurred if object A's left is more left than object B's right. Object A's right is more right than object B's left. Object A's top is more top than object B's bottom, and object A's bottom is more bottom than object B's top. So basically, if your left is more left than your right is more right than your left, your up is more up than your down, and your down is more down than your up, you know you have collision, and we can detect that. And what that looks like for us is just a 4-part if statement. So I'm going to say, also, note that our bullet does not have a bounding box. Our bullet is so small that we're just going to use a point. We're going to use the x and the y of the bullet to represent the single point of the bullet. And so collision detection on our bullet is really easy. We're just checking to see if the x and y is within the bounds of the bounding box of the other object. So I'm going to do if bullet sub I dot x is greater than, then I'm going to put some parentheses here, comments sub j dot x minus comments sub j dot bound x. Okay, so basically we're saying we're taking comment sub j, so our comment, right, and we're like and subtracting the bounding box from that, or the bound x, which means we're looking at the left side of the object. So we're basically saying that the bullet's x coordinate has to be greater than the left side of the comment. All right, so it's more right than the comment's left. Okay, and then I have my and statement there, and I'm going to do bullet sub I dot x is less than comments sub j dot x plus comments sub j dot bound x. Okay, and now we're saying the x coordinate has to be smaller than the x coordinate of the comment plus the bounding box of the comment. So that means the right side of the comment. So to be true so far, the x of the bullet has to be to the right of the left side of the comment and to the left of the right side of the comment. So we're in between the left and the right side. But that's only half of it. Now we have to test the up and the down. That looks like this. Bullet sub I dot y is greater than comments sub j dot y minus comments sub j dot bound y. All right. So now we're saying basically if the y is greater than comments y minus comments bound y, so the top, right, of the object. So basically the bullet has to be lower than the top of the comment. And then the last part, bullet sub I dot y has to be smaller than comment sub j dot y plus comment sub j dot bound y. All right, and so finally the y value has to be smaller than or higher than the y of the comet plus the bounding box of the comet. So we know that if this is true, then the bullet is in between the left and right bounds of our comet and in between the top and bottom bounds of our comet. If all four of those are true, we have collision. If they're not, we do not have collision. And then if they're true, I'm going to say bullet sub I dot live equals false. The bullet is dead because it collided. And comet sub j dot live equals false. Alright, we're not doing any scoring or anything yet. That comes with the game logic that we're going to add in the next video. Basically, this is the summation of collision detection right here. If there's any part to understand of this entire game, this is the part to understand. Because I know it can sound kind of confusing. It's really not all that bad, and if you're having trouble with it, get out a piece of graph paper, and kind of graph it out, and you'll see that it makes a lot more sense. Okay, so now we have our collision function good to go, already made here. So what we have to do is we have to plug it in now. So basically, in a game that had classes, right, where our ship and our bullets were more of objects, right, the object-oriented programming and all that, we would do the collision detection a little bit differently. But since we're not working with that type of environment, we're just working with functions, we're going to follow the update with our collision detection. So essentially what this means is that after all of our objects move, we're going to test to see if they are now colliding. Okay? Doing it the opposite direction will work, but it means we're being delayed one tick, because that means we're checking for collision, then we're moving, and we might be moving into a collision scenario, but we won't test for that collision scenario until the next iteration. So we're going to update, and then we're going to check for collisions. And we're going to do collide bullet, and we're going to pass in our bullet array, our num bullets, our comets array, and our num comets. And that array is actually called bullets. I apologize. Okay, so great. So now it's plugged in. Let's go ahead and run this. And we'll see, bam, bam. So now our collision detection is working. You can see I can actually scalp the very top of these objects would not register a collision because the bounding box is smaller than the actual object. But it's not too problematic. And we could adjust that if we really wanted to. But you can see now we have our collision detection of the game, and we could do things like adding explosion animations and whatnot, but that's outside the bounds of this game. So for all intents and purposes, the objects are just being destroyed, being set to not alive, and then they're not rendering. Alright, great. So that's one half of our collision detection. Let's handle the second half. We are colliding our bullets, but one more thing has to happen. Our comets have to be able to collide with the player. And to do that, we're going to use a function that's called, no surprise here, collide comets. And in there, we're going to pass comet array in. We're going to do our C size, and we're going to pass in our spaceship because we need to know the location of the player object. Great, and I'll just copy that. Let's scroll on down here to the bottom. I'll paste it, and we can get to work with that. So, once again, we're going to have our for loop where we're going to loop through all of our comets. So we'll do for in I equals 0, I is less than C size, I plus, and then we're going to test to see if the comet's alive. If comet sub I not live. Alright, now, this collision detection is going to be pretty much the same. You know, left is more left than right, right is more right than left, up is more up than down, and down is more down than up. But we're not using just an X coordinate and a Y coordinate anymore. We're using the bounding boxes of two objects that have width and height. So the bullet, we were just checking the X and the Y because it was so small and traveling so fast that we didn't really need any more accuracy than that. In this, we need more accuracy than that. We need to check for more than just the x and y coordinate of the ship. We need to check for the whole bounding box of the ship. While the Comet's bounding box was easy, we could theoretically even have used a circle. It doesn't really matter. The ship is a very peculiar shape. It's a triangle, yes, but it also has those turrets sticking out and things like that. So to make our collision detection more accurate, we have to essentially make the bounding box of a certain size that while we give up some collision on the wings, meaning we could potentially have a comet graze the wings and not register a collision, we also gain the benefit of not having so much empty space that's collidable. And so our bounding box, which we've already determined in the objects, basically makes that negotiation, that compromise, where our collision is slightly inaccurate, but more believable. So what I'm going to say here is basically if the comet's alive, I'm going to do if comets sub I dot x minus comets sub I dot bound x is less than ship dot x plus ship dot bound x. Alright, so what we're saying is if the left side of comet is more left than the right side of the ship, okay, that's what that effectively is saying, and if comet sub I dot x is greater plus comets sub I dot bound x is greater than ship dot x minus ship dot bound x. Alright, so this means that if the right side of the comet is more right than the left side of the ship, and then further on, comets I dot y minus comets sub I bound y is less than ship dot y plus ship dot bound y, and that just means if the comet's top is is higher than the ship's bottom, and then if comets sub I dot y plus comets sub I dot bound y is greater than, so if the comet's bottom is lower than the ship's top, alright, if all that is true, we have collision. Alright, and so if we collide, we're going to ship lives minus, we lose a life, and comet sub I dot live equals false. Alright, there's one thing else we have to check for, and what that is we have to check to see if the comet has gone off the screen. And if it goes off the screen, two things are going to happen in this game. One, it's going to be set to dead, live is going to be set to false, it's going to be destroyed, and we're going to remove a player's life. So the player needs to catch all of the comets or else they'll lose even if they don't get hit by a comet. Now if you remember, in our update comet function, we actually check right here to see if we've gone off screen. Now that we have our collision function, we're actually going to cut this code out of here and we're going to move it. And the reason we're going to do that is so that if the comet goes off screen, so I'm going to do an else and then place the if there. So if the comet goes off screen, something that we couldn't do in the previous function, we are going to do ship.lives minus minus. Okay. So if the comet collides with the screen, the edge of the screen, we're going to have it be killed, so to speak, and then we're also going to decrement the lives of the player. And the reason we could not do that in our update comet function is because we don't read in the ship up here, but we do read in the ship over here. So while it may not make the greatest of sense to move our bounds checking out of the update function, for this simple example, it makes the most sense so that we don't have to read ship in up here at the top. We keep all of the ship life decrementation, if you will, out of or in the same location. Now before I run this, we have to plug it in just like we did with the bullets. So I'm going to come up here to our update, and I'm going to type in collide comments, and I'm going to pass in comments, and I'm going to pass in num comments, and I'm going to pass in ship. Alright, great. So what we're going to see here when I run this is we don't have any way of knowing our lives yet, and even when we run out of lives, it doesn't do anything, because that's in our game logic, which we'll see here shortly. But what we will see is collision. Alright? So meteors are or comets are being destroyed when they collide with the ship. So I can either shoot the comets, or I can have the comets collide with me, and the lives are being decremented on the ship, but since we're not actually doing any game logic to that, it has no real effect yet. So that is collision detection in our game. I would advise that if you're having difficulty understanding the bounding of the collision detection, that you absolutely go back, rewatch the video, or at least look at the source code for the bounding collision detection. Right, the left more left than right, right more right than left, up more up than down, and down more down than up. That's very important, especially in 2D space, in dictating how collision detections have, or how collision has occurred, and that's a very important part of this part 5 to our series.